Okay, hi everybody, welcome to homework 1.13. Today we looked at substitution in systems of equations, and I'm going to go ahead and warn you that today's homework is not that difficult, but it does take a long time, so it's going to take a minute for you to do all of this, all right? So we're going to start. Our first one here has a y equals 6x minus 11, so we already have a variable solved for. So since it's already with y equals, I'm going to take this whole chunk right here, and I'm going to put it in place of y here. So I'm going to rewrite this as negative 2x minus 3 times 6x minus 11 equals negative 7. So again, what I did there is I'm just taking this y value and I'm replacing it with 6x equals 11 because that's what y equals. So now I can do negative 2x, and I'm going to go ahead and use my distributive property and multiply negative 3 times what's inside my parentheses. Now notice here that this negative 3 has a negative number, and so negative 3 times positive 6 is going to be negative 18x. And then negative 3 times negative 11 is going to give us a positive 33 equals negative 7. Remember to drop down the other parts of the equation after you've substituted, right? That negative 7 on the other side of the equal sign is still important. Now I'm going to combine like terms. I can combine negative 2x and negative 18x because they both have x's, and so that's going to be negative 20x plus 33 equals negative 7. I'm going to subtract 33 from both sides because 33 minus 33 will give me 0. I get negative 20x equals negative 7, and negative 33 is going to give me a negative 40. Divide both sides by negative 20 because I'm doing that inverse operation, and I'm going to get x equals negative 40 divided by negative 20 is going to be positive 2. Now I have what x equals, but I need to figure out what y equals. So I'm going to plug in x here because that'll tell me what y equals. So 6 times 2 minus 11 gives me 12 minus 11, which is 1. So our full answer for this is x equals 2 and y equals 1. That is my full and beautiful answer there. Okay? Let's take a look at the next one. So also in number 2, we're really lucky in that this is already solved with y equals for us right here, right? We already have that there. So I'm going to go ahead and take this whole piece and plug it in wherever I see y in the other equation. And so let's rewrite this as 2x minus 3 times x minus 1 equals negative 1. Now again, same thing here. I need to multiply this negative 3 times everything in the parentheses, and I have to be careful with that negative. So I'm going to bring down my 2x. Negative 3 times x is going to be negative 3x. Negative 3 times negative 1 is going to give me positive 3 equals negative 1. Now, same thing, I'm going to combine my like terms. So negative 2x minus 3x, or sorry, 2x minus 3x is going to give me negative x plus 3 equals negative 1. I'm going to subtract 3 from both sides because 3 minus 3 gives me 0. I'll get negative x equals negative 4. And then we have a negative, right? So I want to neutralize that negative. I'm going to multiply the whole thing by negative 1, and we'll end up with x equals 4. Now that I have that, I can solve for y. So y equals 4 minus 1, or x minus 1. Instead of the x, I'm putting that 4, so y equals 3. So now our full answer is 4, 3. And if you want to see if you have the right answer, you can take it and you can plug them back in. You just need to make sure they work in both equations. So 2 times 4 is 8. Minus 9 gives us negative 1. That works. And then 3 equals 4 minus 1 also works. So we know that that is a correct answer. Let's try this next one. This next one, we also have the y equals given to us already right here. And so we can plug in that whole thing where we see a y here. So let's do that. So we have 5x minus 4 times negative 3x plus 5 equals negative 3. Now I need to distribute, so I'm going to do 5x. Negative 4 times negative 3x is positive 12x. Negative 4 times positive 5 is minus 20 equals negative 3. combining these, we get 17x minus 20 equals negative 3. I'm going to add 20 to both sides, and we'll get 17x equals 17. Divide both sides by 17. This means that x equals 1. I have the first answer now here, and so I'm going to go ahead and I'm going to go ahead and plug that in to get my other value. If I plug in negative 1 for x, I get, or sorry, positive 1. Positive 1 times negative 3 gives me negative 3. Oh, what's going on here? Plus 5 equals 2. So that would be my y value of 2, and we can confirm that if I do negative 3 plus 5, that equals 2. If I do 5 minus 8, I do in fact get negative 3, so that checks out. So our answer is 1, 2 for number 3. All right, let's go ahead and try our next one. So here we have, again, our y equals already is solved for, so I'm going to replace the y in this equation here. So I have negative 3x minus 3 times negative 5x minus 17 equals 3. Now I'm going to distribute this negative 3. Remember, the sign needs to stay with that negative 3. So negative 3 times negative 5x is plus 15x. Negative 3 times negative 17, a negative times a negative gives us a positive. We have 21, carry the 2, so 51 equals 3. Now I can combine negative 3x and positive 15x is going to give me 12x plus 51 equals 3. I'm going to subtract 51 from both sides to make this 0, and then 12x equals negative 48. Therefore, x equals negative 4 if we divide both sides by 12. Okay? Now that I have that negative 4, I can plug that back in to solve for y. So negative 5 times negative 4 is 20, minus 17 is 3, so this means that y equals 3. Negative 4, 3 is my answer. Okay? All right, so numbers 5 and 6 I'm going to have you do on your own, okay? Again, numbers 5 and 6 you're going to do on your own because, again, the y is already solved for in both of these. All you have to do is take these and plop them where you have a y in the other equation. I am going to go ahead and skip down to number 7 now and model for you what this should look like. So for this one, I'm going to solve for y here. And it doesn't matter which equation you choose as long as you substitute it back into the other equation. The reason I'm going to do this one is if I add 4x to both sides, I end up with y equals, this will cancel out, 4x plus 6. That's a pretty nice number for me to go ahead and substitute into the other equation. And remember, I'm plopping that in, this right here, in wherever I see a y here. So I do see that there's a negative in front of the y, so I'm going to have to be careful and remember to use my parentheses. So negative 5x minus this whole thing. So 4x plus 6 equals 21. Now the reason these parentheses are so important is because this is really a negative 1 in front of here. And so I have to distribute the negative through those parentheses. Negative 5x minus 4x minus 6 equals 21. And now we're going to end up with negative 9x minus 6 equals 21. I'm going to add that 6 to both sides because that'll cancel out, and then I get negative 9x equals 27. And I can divide both sides by negative 9, and I will get x equals negative 3. So now I have the first part of this at negative 3, and I'm going to go back and plug it in to solve for y. So if I plug this 3 in here, I get negative 12 plus 6, and so that's going to give me negative 6. And I can go ahead and check that answer and make sure that it works. So if I look back at my original equation, if I plug in negative 3 times 4, negative 4 gives me 12, plus negative 6 does in fact give me 6. If I try in the other equation, negative 5 times negative 3 is 15, minus a negative 6 is going to be 15 plus 6. That does equal 21. Check, I know it works. Okay? Let's look at number 8. Number 8, I'm going to solve for this one down here because I don't have a coefficient of x. So for this one, I can add 2y to both sides, and I'll get x equals 2y plus 11, or 11 plus 2y. Both are perfectly valid. I'm going to do negative 7 times, now in this case, I'm not replacing the y, I'm replacing the x. So I'm going to do negative 7 times 2y plus 11 equals negative 13. All right, so, now look, see? I just realized, as soon as I did it, I realized I made a mistake. So here, I also have to have this minus 2y equals negative 13. All right, so that's why it's important. Actually, I suggest you write the equation, negative 7. I'm going to fill in that first, and then fill in what you're going to substitute, just so you don't forget to write the rest of the equation like I did. All right, so I'm going to distribute this. Negative 7 times positive 2 is negative 14y. Negative 7 times positive 11 is negative 77. Minus 2y equals negative 13. I'm going to combine negative 14y and negative 2y to be negative 16y. Minus 77 equals negative 13. And I'm going to add 77 now to both sides, because we want negative 77 and positive 77 will be 0. And I get negative 16y equals, so this is a negative 13 and a positive 77, which will give me 64. And then I'm going to divide both sides by negative 16. And 64 divided by negative 16, plug that into your calculator if you want, or you might recognize that this instantly is going to be 4, but it's a positive divided by a negative, so this is going to be y equals negative 4. Now we have one of our answers. I'm going to go back and plug it in to solve for x. So negative 4 times 2 is negative 8 plus 11 equals 3. So x equals 3. This time our value is 3 comma negative 4. All right. And again, you can check your answers and make sure you got that right. All right. I'm going to go ahead and show you, whoops, I'm not sure what's going on there. There we go. I'm going to go ahead and show you one more with number 9, and then I want you to do 10 by yourself. So similarly to the last one, y is already by itself here. So I'm going to use the first equation and solve for y, because that seems like the easiest thing to solve for, by adding 5x to both sides. So this will give me y equals 5x minus 2. I'm going to substitute that in here into the other equation. So now this is what y equals. It's going to go in there. And I'm going to substitute negative 3x plus 6, open parentheses, I'll go back and put it in, equals negative 12, so I don't forget anything. And instead of y, I'm substituting 5x minus 2. So we get negative 3x. I'm going to do 6 times 5 is 30x. 6 times negative 2 is negative 12 equals negative 12. All right, so now I'm going to combine these, and I'm going to get 27x, okay, minus 12 equals negative 12. I'm going to add 12 to both sides. Now, interestingly, what happens when I do that is this is going to be 0, but this is also going to equal 0. So now I have 27x equals 0. Well, the only thing then that will work for x is 0. So that means that x equals 0 in this equation. If I plug that back out in here, that means we would have 0 plus y equals negative 2. So that means y equals negative 2. All right, and you can test that out, try it out, make sure it works in both equations, and you'll see that it does. If it's helpful for you on your paper, use a highlighter. All right, so number 10, you're going to do on your own because you just saw me model for it. My hint is to solve for y here first, okay? Solve for y here first, and then plug it into the other equation. All right, let's look at Lynn. Lynn is solving the system of equations. She starts by rearranging the second equation to isolate the y variable, y equals 4 minus 1.5x. She then substituted the expression 4 minus 1.5x for y in the first equation as shown. So she took this equation, okay, and she solved for y and came up with this. And then she put that in this equation where the y is. All right, she got this answer, so we want to see if that makes both equations true because we're going to check out her work and test out her work. So if we do, let's look at the first equation. 6 times x is negative 36 minus 5 times 58 equals 34. Now I can see immediately that this is going to give me a really big negative number, this is going to give me a pretty big negative number, and this is 34, a positive number. So automatically I can say that no, this does not work. If you were to calculate it, you would get negative 216 minus 290, and that obviously is not equal to 34. Okay? In the second equation, though, if we do 3 times negative 36 plus 2 times 58, we end up with negative 108 plus 116 equals 8, and that's what we have here, equals 8. So that does work. So these two values work in the second equation, but not in the first equation. So this is not true for the system of equations. It is true for one of them, but not for the system. So it says if your answer to the previous question is no, which it is, find and explain her mistake. So let's go back up and check her work. So she substituted 4 minus 1.5x in for y here. And then we know that the first thing we need to do is that we need to go ahead and we need to distribute negative 5 through the parentheses. So let's see if she did that correctly. So we would have 6x, negative 5 times 4 gives us negative 20, negative 5 times negative 1.5. All right, so if you calculate that, negative 5 times negative 1.5, let's see, is going to give us negative times a negative is going to give us positive 7.5x. Ooh, so notice that when she wrote it, she wrote this as a negative. So automatically I can see right here where her mistake was. She did not distribute the negative properly. And that's really important. Remember that negative 5, that negative in front of the 5 right here, this right here, needs to be distributed, right? So we have a negative times a positive, a negative times a negative. And so this should be a positive, and then she would have done it correctly. All right, number 2 says solve each system of equations. You can do this. You can practice this. You already have x equals 4, so you know one of the answers is 4. Now you go back and plug that in. 2 times 4 minus 4y equals 20. 8 minus 4y equals 20. I want to get rid of this 8, so I'm going to subtract 8 on both sides. We get negative 4y equals 12. Divide both sides by negative 4. Y equals negative 3. That's your answer. Okay. The second one here, you have this here. You need to plug that in for y down here and solve. For this one, I'm going to go ahead and tell you that you're going to get like not the most beautiful number for your x value. That's your hint that I'm going to give you. So check your work, but you're not going to get a perfectly even number necessarily. All right, so take your time, work through it. You will get it, but it's going to take you a little bit more work maybe than the other one because of some of your values here. Okay? All right, so do by yourself. You can do it. Number 3. Tyler and Han are trying to solve this system by substitution. So they're trying to solve this right here. Tyler's first step is to isolate x in the first equation and get x equals negative 5 minus 3y. So he said x plus 3y equals negative 5. I want x by itself, so I'm going to subtract 3y from both sides. And gets x equals negative 5 minus 3y, or negative 3y minus 5, however you want to do it. All right, show that, and then so he says Tyler's first step is to do this. Han's first step is to isolate 3y in the first equation and get this. Show that both first steps can be used to solve the system and will yield the same solution. So in this case, we want to prove both ways work. So let's continue Tyler's work first. So Tyler has x equals negative 5 minus 3y. So then we're going to plug that into this equation for x. So 9 times negative 5 minus 3y plus 3y equals 3. Okay, so 9 times negative 5 is negative 45. 9 times negative 3y is negative 27y plus 3y equals 3. So we're going to have negative 45 minus 24y equals 3. Add 45 to both sides. We get negative 24y equals 48. Y then equals negative 2. Because if we divide both sides by negative 24, we'll get y equals negative 2 as our answer. If I plug that back into the other equation, I will get x plus negative 6 equals negative 5. Add 6 to both sides. We will get x equals 1. All right, so the first way that we do this, we get x equals 1 comma negative 2. Let's try Han's way. So Han decided to make things a little bit more complicated, and he used the second equation and said, okay, we have 3y equals negative 5 minus x. All right, so now I would have to solve for y and divide both sides by 3. So we get y equals negative 5 over 3 minus 1/3 x, or minus x over 3. Either way that you want to write it is fine. Now I have to take this and substitute into the other equation for y. So we have x plus 3 times, sorry, my alarm, x times 3, x plus 3 times open parentheses equals negative 5. And we're going to plug this whole thing in for y. So negative 5 over 3 minus 1/3 x. Now I'm going to distribute my 3 here. So we get x equals, or x plus 3 times negative 5 is negative 15. And then negative 15 divided by 3 is very simply negative 5. So this is going to be negative 5. I'm going to put it in parentheses so it doesn't get mixed up with that plus. And then 3 times negative 1/3. Again, we're going to have a negative here. 3 times 1 is 3, divided by 3 is 1. So minus 1x, or just minus x, equals negative 5. Now I have, I can go ahead and combine here. Oh, you guys, you see? Let's see here. Make sure I did this right. Oh, I see. Nope. This is what I did wrong. Okay. So in Han's situation, I'm sorry, this is my bad. He solved from this equation, not from the second. So I needed to plug it into the second equation. This is why we have to be careful with this. That's why looking at other people's work can sometimes be a little tricky. So, see? Here we go. Roll it back. All right. So Han isolated the 3y here. So that was my bad. So he got 3y equals negative 5 minus x. Divide both sides by 3. We're still going to get y equals negative 5/3 minus x over 3. The mistake that I made is I plugged it back into this equation, and we need to plug it into the second equation. So 9x plus 3 times negative 5/3 minus x over 3, close parentheses, equals 3. Okay, so again, Miss Lee made a mistake because I plugged the equation back into the same equation, and that's going to mess us up. So you have to plug what you get when you solve for y here into the second equation. So we have 9x, and again, 3 times negative 5 is negative 15, divided by 3 is going to be negative 5. 3 times negative x over 3 is going to be just negative 1, or negative 1x. and then equals 3. So now I can combine like terms. 9x minus x gives me 8x, minus 5 equals 3. I'm going to add 5 to both sides, and I get 8x equals 8, which means that x equals 1. Now notice, that's also what I got over here. So 1 comma, now we need to figure out what we would get for y. So if I plug in 1 plus 3y equals negative 5, subtract 1 from both sides, we get 3y equals negative 6, divide both sides by 3, y equals negative 2. So notice that we did it differently, but we got the same answer. So the difference between Tyler and Han is that Tyler solved for x up here, and Han solved for y over here. But again, they still got the same answer. Quite frankly, I would never want to do it the way that the way that Han did it. This way is way too messy, in my personal opinion. I would prefer to do it the way that Tyler did it, but you can also, as you're doing this, figure out which way you think is best. Generally, putting myself in a situation where I'm working with fractions isn't my ideal, but you can do it, okay? And again, once you solve for a variable in the first equation, make sure that you're then plugging whatever you get in into the second equation so you don't make the same mistake that I did. All right, that is your homework video for today. If you have any questions, feel free to text me or reach out, and I will see you tomorrow. Your code word for today is Pringles, okay? Code word for today is Pringles. Put that at the top of your paper, get extra credit, and I'll see you tomorrow.